Hello my friends, it's been a while since we made our last video, but there was a reason for that. We were busy, we were very busy, and we were working on something really new, something revolutionary new. And now I'm happy to present it to you. Ladies and gentlemen, please welcome Helidon 4. Okay, you may say this is yet another major release of the famous microservices framework. Yes and no. Of course, there are a lot of new features. Of course, there are bug fixes. Of course, there are a lot of optimizations. And of course, there are a lot of new functionalities. For example, Helidon MP now supports microprofile version 6. That's very nice. But what makes this release so unique? Let me tell you a story. As you know, Helidon major releases are usually aligned with Java LTS releases. Helidon philosophy from the very beginning was to use the latest and greatest features in Java and promote them to our users. In Helidon 1, for example, we adopted everything from Java 8 and microprofile 3.2. In Helidon 2, which was released in 2020, we moved to Java 11, which allowed modularity and provided so-called reactive APIs. That means that the code of Helidon was modular and it was using the latest and greatest features of Java at that moment, this reactive APIs. In Helidon 3, released in 2022, we moved to Java 17. And in Java 17, we used a lot of new optimizations and other constructions like sweet expressions like record, etc., etc. And we also moved to Jakarta namespace. And now, with Helidon 4, we are aligned with Java 21 and microprofile 6. So, what makes this alignment so cool? In Java 21, there are a lot of awesome features and a lot of optimizations as well. But the true game changer are the virtual threads. Earlier, they were available in the project called Project Loom, in the research project, and now they are generally available. If previously threads were quite an expensive resource, delivering a lot of headaches to developers, now you can simply create millions of them. For each task, you can simply create a thread, do the task there, and throw the thread away. As easy as that. As you may have heard in different presentations and conference talks that happened recently, by API, virtual threads are the same as regular normal threads that we used to have. In virtual threads world, these normal threads are now called carrier threads. The main idea is that you create a virtual thread, you assign some work to be done in this virtual thread, and the JVM finds a suitable carrier thread and mounts this virtual thread over this carrier thread to do its work. Whenever a virtual thread blocks, for example, caused by some I/O operation or database call, it is unmounted from the carrier, thus giving room to other threads to do its job. So whenever this I/O or other blocking operation is over, the virtual thread is unblocked. The scheduler will try to find a suitable carrier thread and actually mount it back on it. For this, the fork join pool is used with work stealing for carrier threads, and that actually makes a lot of magic, and that makes them so cool and optimal. As you know, virtual thread have the same properties, the same API as normal carrier threads, so they're very, very easy to learn. And underneath, all these transitions from one cat to another thread are implemented with continuation, especially this special yield function. There is no external API for that, so we let the JVM actually manage it for us. And so we began wondering, are we actually able to adopt these virtual threads in our Helidon world? As you see, virtual threads are extremely effective where there are a lot of them. When the tasks they are performing are short, they do not obstruct the thread. And actually, this is what happens in the microservices world. The requests and responses are quite short, and they don't obstruct the thread. We don't do a lot of CPU calculations during these things. And The only thing that blocks us are typically some DB call, other REST services calls, and maybe I/O operations. So we decided to give it a try. As you know, for maximum performance, we choose netty as a foundation for our framework, and netty is asynchronous. Those paradigm was the only way to achieve maximum performance. And Helidon team has created its own reactive engine and a rich set of reactive APIs. From early days of Project Loom, we in Helidon were experimenting with it, and starting from version 3, with help of some flags, users were able to run netty with virtual thread pool executor service underneath, and there were some really impressive performance results. But that was only a partial solution. So running asynchronous stuff on synchronous virtual threads actually produced more overhead, and the full potential of virtual threads was not used. So we decided to give it a try. We decided to completely throw away netty and create our own small web server written from scratch and written in a completely blocking paradigm without all of this asynchronous and reactive stuff. As you know, as I told already, the nature are tasks that are really short-living, which do not obstruct threads, are extremely suitable for this situation. So our colleague Thomas Lange, the architect of Helidon, has created a really small prototype, a web server which runs only on virtual threads with fully blocking code in it. And we were impressed. With very first runs, the performance of our very basic virtual thread-based server was comparable to the major, very much optimized engine, netty. So we demonstrated this to the JVM guys, and they were so much impressed that we decided to continue the development in tight cooperation with JVM engineers. And like in every very cool movie, we decided to give a project a name, so we called it Nema, which means thread in Greek. So the development was actually very challenging for both sides. We did a lot of optimizations in Helidon and JVM as well. So the main problem was actually the most strange one. We had to unlearn reactive to do the most effective code possible. Through all of these years coding reactive in an asynchronous way, our brain was so much damaged by all of these patterns that we instinctively wrote the stuff in an asynchronous way, which was not optimal. So we had to rewrite everything in most easy way possible, actually like we did in school, and that made the service run so fast. As a result, Helidon architecture looks this way. As you see, there is no more netty, as we moved to our own Helidon web server, which previously was called actually Helidon Nema. As you see, Helidon SE has currently no more reactive APIs and no more reactive engine, since we decided to completely deprecate them and rewrite everything in a complete blocking way. So now we have everything which we need for a virtual thread-based server to run our microservices. That means that from out of the box, we support HTTP1 protocol with full pipelining, we support HTTP2 protocol, we support gRPC protocol, which we actually have to rewrite our own way, and now it's able to run on the same port as other services. We have full WebSocket support. For development, we have wonderful unit test integration frameworks that we created for that. And for security, we have TLS and MTLS support. Framework itself is very much extensible, so we support other protocols. They can be HTTP or non-HTTP protocols. So there is full access log support, full core support, we support static content, of course open telemetry because it's highly demanded now on the market, and to run everything nicely in the clouds, there is a nice observability support. So we have health checks, metrics. we have logging observability, we have configuration observability, everything you need for good telemetry of your microservices in the cloud. And what's good is that those features were implemented from scratch using the latest and greatest technologies provided with Java. So that means, yes, of course, we have virtual threads in the foundation. We use hand switching, we use seal classes, we use system logger, and a lot of other cool new features provided by Java 21. So we are very modern. And that's what makes Helidon 4 so revolutionary. Now let me try to demonstrate in very simplified way how Helidon used to work before and how it works now. Imagine several requests are coming to Helidon and this request forms several tasks which Helidon has to manage, and we have only 2 threads to run them over. So the green tasks here are those who don't take much time and they complete really fast. And the red tasks are blocking operation tasks. For example, calling some database or calling external service, so they take much time and they are running slow. So what will Helidon do? So it will take 2 tasks and run them in parallel. Then those 2 tasks will call back the other tasks which are depending on them, and they will run over those threads. See down below there are other tasks that also had to be managed somehow. And now if one task is over, we have to put the task that we have in memory. So as the persist database task is running slow, it will go back to this pool of tasks. Now, the in-memory task is completely call back the other send message task. And now, as the other blocking operation is over, we may take from the pool this blocking operation with persist to DB. So it is complicated, and as we usually say, there is a lot of magic happening in this reactive engine. Now let's have a look how these operations will be done in Helidon 4 based on the virtual threads. Now following the same pattern, several requests are coming to Helidon. Now for each request we start a new virtual thread with a set of tasks that had to be done to perform this request and form a response. As you see, we for example have only 3 threads, so some of the threads are stopped for now. And we go. As we go, we hit one thread that actually has a blocking operation. And Helidon knows about this. Actually, the JVM knows about this blocking operation. So what it does, it offloads this virtual threads from the carrier threads and loads another thread that can do some job. So we go away, we see that another head thread hits something which is blocking. So the scheduler of JVM finds another thread which is ready to perform some work. So it does the work, and as we go, some of the work is simply done. So we simply stop the thread and throw it away and send the response to our users. Now, as we have some more work to do, you see we just keep going, and as all the responses are sent, we had only one thread here in this example, which actually is about to get waken up, to mount a carrier thread, and to send a response back. So as easy as that, and that makes the huge difference. And the main difference from the other framework is actually that, unlike those other frameworks, Helidon is fully based on virtual threads. Many frameworks declare that they do support virtual threads, but most of them at this moment of time actually support only virtual thread pool executors, which are mounted over some NetT servers or other servers. So this is the huge difference. Helidon 4 is fully virtual thread based server. There is no other overhead. Pure blocking paradigm, which is managed by JVM, and this allows ultimate performance. Well, that's not all. Actually, the side effect of this massive change, I would say, is that the users of Helidon really don't need to write more reactive code at all. So we get the same performance with blocking code. That means that the user of Helidon can simply write the business logic like they used to do it, like, I don't know, in school in 7th grade, and they will run with the same speed, with the same performance as if it was written in reactive paradigm. And as you understand, this simply written code is much easier to run, maintain, and debug. Well, let us have a look at a small example. So here we want to send multiple requests in parallel to some outer service in while doing actually one response. So this is a very efficient code. It's written in reactive way using our previous reactive construction. And what we have here, I would be quite honest, I am not the best person in reactive programming, so this code was created by our expert in reactive programming, and it actually took him a while to create it. So what we see here is that for some range in counts, we create a completable future when we supply asynchronous executor, and which we actually send us to send request to external server. When we then flat map all this result that we have using something called function identity. I really don't know what it is, but experts in reactive programming know that very good. And then we collect this result to list, and then we actually map it to some strings. And then if there was an error, so we simply handle it gracefully in a reactive way. Otherwise, we created a single and we sent this single as a string to our customers. Well, that was hard, I would say, but this is very efficient. This is what we do to actually have a lot of performance. But now in Helidon 4, the same stuff will look, I would say, much more familiar to most of us. So what we do here, as I said, virtual threads are at easy, very cheap cost right now. So if we need to create a task, a future with task, we simply create a task, we fire it, and whenever it's done, we throw it away. So what it's done here, so we create a pool of virtual threads of some count. For each task, as we want to call some outer service in parallel, we just create a future with it. We just submit this lambda with calling task to this future. We fire it and we forget it. And then we just get the responses. Well, this may sound very inefficient as it's written right now because first of all it creates a lot of threads, then some of them will call other services, and we should gather the results, and then we should actually print the result. Yes, but in this case JVM actually manages for us uh, what threads actually do and how they do it. So that means that all this will be done in virtual threads, and once again, as in previous code, it will be done in a very efficient way. But as you see, it's much more readable and much more debuggable. So now as you see, it's very easy to create very efficient microservices in Helidon 4. And as another side effect of that will be a great performance boost in Helidon MP. As you know, Helidon MP is based on microprofile. A microprofile itself, as a set of specifications, is mostly blocking. That means that all the APIs that it provides are actually blocking. So if we run this blocking applications on Helidon 4, which is based on blocking web server, which is based on virtual thread, we can see a massive performance boost. Sometimes orders like hundreds of percent. That means that all the Helidon MP users, if they migrate their application from Helidon 3 to Helidon 4, which is extremely easy, so you just Just change the version, because once again, microprofile is a standard. They will get a massive performance boost actually for free without any requirements to do something additional from their side. And this is awesome. Well, I believe this is pretty cool. So now, since Helidon 4 is officially available and officially released, simply go to helidon.io website and start using Helidon. You can go to the starter page and easily create your Helidon applications. As easy as that. With this, I want to say a big thank you for watching this video. On behalf of the Helidon team, I sincerely hope that you will start using the revolutionary Helidon 4 in your projects. So, have fun creating awesome microservices. Bye bye.